Children are afraid of the dark, but utility companies, they're afraid of the light. They're afraid of solar photovoltaics or PV power because they can't control it. Unlike conventional coal power plants that can just run straight out until you turn them off, solar PV power is variable due to the passing of clouds. So why is this scary to them? It's scary to energy companies because their job is to maintain a reliable power grid by constantly balancing energy supply with energy demand. So if you have a supply source that you can't control, like solar PV power, that's scary to them. That's very scary. So specifically what they're afraid of is what I'm showing in the top figure here. This is irradiance, which is just a measure of incoming sunlight power, measured at a single point sensor like the one in the picture that I'm shown working on. So this is irradiance measured over a 1 hour period, and you can see that if you look at this as an energy company, you might think that this translates directly to the power of a solar PV power plant. And as you can see, this power is dropping up and down with the passage of clouds. It's going from, let's say, 50% of its total output to 100% very quickly, almost instantaneously, as a cloud passes over a sensor. So this is very terrifying to them, right? But what I look at in my research is what happens if you take 25 or a whole bunch of sensors like that and put them over the entire area of a power plant. So in the second figure here, we have the black line, which is that same single sensor. And then we have a variety of other colored lines, and those are the other 25 sensors that are just a couple hundred feet apart. And so what you see is that as a cloud passes over that whole area, each sensor sees something different at a slightly different instant. And this results in spatial smoothing. So my research looks at how we predict spatial smoothing, which is shown in the bottom figure. So there you have the same black line from a single sensor, and then you have the blue line, which shows the smoothed irradiance, which is basically kind of an averaging of all of those other sensors. And so if you compare those two lines, you have the scary black line that's jumping up and down, and then you have the friendly blue line. And this has much lower slopes. It's just a gradual changes, and a lot of those really quick changes are completely erased. So this is much easier for power companies to imagine incorporating into the grid, and will cause many fewer problems. So my research looks at how we predict this nice blue line, and preferably how do we predict that without using all 25 sensors. So in conclusion, solar spatial smoothing greatly reduces PV variability, and this is good news for the power grid. So I say, bring it on. Let's take advantage of this abundant resource in the Southwest to create clean energy. Thank you.